Chapter 6, Section 4, Elimination using Multiplication. We have our lesson menu here, telling us we're going to do 3 examples. First, we're going to do our 5-minute check, so using elimination to solve the system of inequalities. So draw our line underneath. We can already see that y minus y goes away. We're left with 8x equals 9 plus 7 is 16. Divide both sides by 8, and we're left with x equals 2. Plug that into either one, it doesn't matter, I'll just do the top one. 5x plus y equals 9, so that's 5 times 2 plus y equals 9. So 10 plus y equals 9. I subtract 10 from both sides. Now I'm left with y equals -1. So I have the point 2, -1. Our answer here is A. So we're going to use elimination to solve the systems of inequations again. Here, I do not see one that can go away really quickly without first subtracting. So I'm going to subtract. If I subtract the 2, I have to subtract the y, I have to subtract the 1. So these go away. I'm left with 3y equals -9. Divide by 3 on both sides, I get y equals -3. I'm going to put the -3 in for y this time. So now I have 2x minus 12 equals -16. Add 12. And I get 2x equals -4. I get x equals -2. So I get -2, -3. And for some reason, I decided that I needed to double the 16 or the 8 into 16. I don't know why. Just magically happened, I guess. Magic doesn't always work, folks. So this is -8. So that means this is a +4, which means that's a +2, which means that's a +2, -3, which is why our answer is B. Let's see, solving using elimination once more. The 3 y's are going to go away. So I'm going to be left with 7x equals 0 divided by 7. And I get x equals 0. 0 minus 2y equals 2. Divided by -2. And I get y equals -1. So this would be 0, -1. Can I do it again? Why, yes, you did, Miss Bass. You are wanting to make things different this morning. -2/3. So 0, -2/3. And look, that is one of our answers. Yay! Find 2 numbers that have a sum of 151 and a difference of 7. There you go. So we have 2x equals 158. We're going to divide by 2. So x will equal 158 divided by 2, 79. So that's one number. Plug it back in. So x plus y equals 151, where x is 79. We will be checking this answer since I seem to not be doing things completely correct. So 151 minus 79 is 72. So let's see. If y is 72, x is 79. 79 plus 72 is 151. Good. 79 minus 72 is 7. Good. And no, you do not want to just go through testing out their numbers. You do want to learn the algebra because, yes, this was a simpler problem, but you need to learn how to set up the simple problems so that the medium and the hard problems are actually hard. Again, 2 consecutive numbers, so one right after the other, like 2 and then 3. Those are consecutive. 4 and 5, 6 and 7, those are all consecutive. So 2 consecutive numbers have a sum of 151 and a difference of 7, and I just redid the whole thing. That slide was in there twice. The student council sold pennants and pom-poms. The pom-poms cost 75 cents more than the pennants. So if we call the pennants X and the pom-poms Y, the pom-poms are going to be 75 cents more than the pennants. 2 pennants and 2 pom-poms cost $6.50. What are the prices for the pennants and the pom-poms? Okay. Since we're saying here that 2 pennants and a pennant is X, so that's 2 pennants plus 2 pom-poms equals $6.50. I'm actually going to go back to substitution on this one. So we have 2x plus 2 times what we know the pom-poms are equals 650. Or take that 2 through. So we get 2x plus $1.50 equals 650. I'm going to subtract $1.50 from both sides. And I'm going to get these two x's together. So we get 4x equals 5 divided by 4. And we end up with x equals $1.25. And x is the pennant, so the pennants are $1.25. And then we plug it back in here. So now we get y equals $1.25 plus 75 cents. And we get that y is equal to $2. Solve the system of inequations below by using the elimination method. Here, it's pretty quick and easy. Divide by 5, and we get x equals 6. Now I plug that in. 6 minus 3y equals 15. So we get negative 3y equals 9. Y equals negative 3. So I have 6, negative 3. Let's see if Miss Base is right with an A. Yay! So now we can get into elimination with multiplication. So before we've used elimination with addition and subtraction to solve equations. Today we're going to solve systems of equations by using elimination with multiplication and real-world problems involving systems of equations. Let's just dive into it here. So using elimination to solve systems of equations. So when we're looking at these problems up here, what I see is that I don't have anything that goes away easily. I do, however, see that I have a y and a 2y. Well, I need that y to cancel out that 2y. Well, if it was a negative 2y, then that would work. So how I can do that is to get that one is if I multiply everything by negative 2 out here. Then I end up with negative 4x minus 2y equal to negative 46. And I have 3x plus 2y equals 37. Now when I add these two together, my 2y's cancel out, and I can do exactly what I have been doing, which is find my x of 9, plug that back in, and we get a y of 5. So the solution is 9 and 5. Let's try one. What do I want to get rid of? The easiest thing I see to get rid of here is going to be the x, which means I need a negative 3x up here. So now I get negative 3x minus 21 equal to a negative 36. And on the bottom, I get 3x minus 5y equal to 10. Add them together. I get a negative 26y is equal to negative 26. I divide by negative 26 on both sides, and I get a y of 1. And I plug that back in. I get x plus 7 11 times 1 equals 12. So x equals 5. So I get 0.51. Yay. Using elimination to solve systems here, and if you notice, neither one of these comes out clean. Okay? What I see right off the bat is I do have a positive and a negative. That's going to help. But what can 3 and 5 both go into so that things zero out? What they did, actually, is they did the 3 and the 4. They made one of them negative. I'm multiplying by negative 4 down here to get negative 12. And they multiplied by a positive 3 up here to get a 12. I would have actually multiplied this by 5 and this by 3 and gotten 20x plus 15y equals 40, and 9x minus 15y is equal to 969, negative 69. And I would have solved from here because those y's would be canceled out. But notice there, 12x's cancel out. You can do it either way. You're going to come up with the same answer. This is all up to you and how you want to do it. Let's do one. So let's try this one. 3x and 2y or 3x and 2x or 2y and 5y. I'm actually going to go with the smaller numbers of 3x and 2x. So I'm going to make one of them negative. It doesn't matter. I'm going to go with negative 2 on top, and I'll go with a 3 multiplied on bottom. So you get negative 6x minus 4y equals negative 20. And we get 6x plus 15y equals 9. 6x's cancel. I'm left with 11y equals negative 11 divided by 11. And I get y equals negative 1. And now I go back to an original equation. 1 or 2, I don't care, but original. So 3x plus 2y equals 10. I get 3x plus 2 times negative 1 equals 10. So 3x minus 2 equals 10. Add 2 to both sides, and we get 3x equals 12. So x equals 4. So we get the point 4, negative 1. So always remember to go back to that original equation when we're plugging back in. Transportation. A fishing boat travels 10 miles downstream in 30 minutes. Return trip takes about 40 minutes. Find the rate in miles per hour of the boat in still water. So the rate of the boat in still water, let's C equal the rate of the current. Use the formula, rate times time equals distance. So RT equals D. And since the rate is miles per hour, write 30 minutes as a half hour and 40 minutes as 2/3 of an hour. Sounds fun. So when we write this out in a table, our rate, we have B plus C for downstream and upstream B minus C. Let's see, T is 1/2, upstream is 2/3. That's half hour and 40 minutes. Distance is the same on each one of these. So we have 1/2 times B plus 1/2 times C equals 10. Rate times time equals distance. Good. 2/3 B minus 2/3 C equals 10. So if you didn't know that B is when you're in a lake, you don't have a current, you don't have anything you're working against, you're just sitting in the water and the boat goes as fast as it goes. If you're in a river, that river is rushing down out of the mountains and it's going all the way to the ocean. So it's pushing in one direction. You can either go with the current or you can go against the current. With the current, you're going to take that speed plus your speed, and so you're going to be going a little faster. Whereas if you're going against the current, that current is going to slow you down. Okay, you're going to have to really work against it. So the B is when you're sitting still, and the C is when you're going upstream against that current. That's why we have downstream plus the current, it helps you, and upstream minus the current. Okay, so all they did here was they got them to be the same. So 1/2 and 2/3. You could have also made them whole numbers. You could have gotten rid of the 3 by multiplying by 3 all the way through and multiplying by 2 all the way through on the top. And then you would have not had to deal with fractions. It would have been an easier way to deal with this problem, actually. In any way, you're going through and doing it the same as we have been. Okay? So a helicopter travels 360 miles with the wind in 3 hours. So with the wind, so a helicopter with the wind, and a helicopter, I'm going to assume minus the wind. Okay, and that was our rate, time, and our distance. Okay, in 3 hours, so the helicopter travels 360 miles in 3 hours. The return trip against the wind takes the helicopter 4 hours, and we're going 360 miles in each one. See how I set it up just like we did before? So we multiply rate times time to equal this. So we get 3h plus 3w equals 360. And we get 4h minus 4w equals 360. We need to get them alike so that we can get rid of one. I see 3w and the 4w here, so I'm just going to multiply by 4, multiply by 3. So I get 12h plus 12w equals 360 times 4 should be 1440. Then I get 12h minus 12w equals 1080. That wind goes away. I'm left with 24h equals, I'm going to add these together, 2,520 divided by 24. I get h equals 105 miles per hour. Find the rate of the helicopter in still air. So I actually already have the speed here, and I don't have to put it back in. 105 miles per hour.